In today's video, we will discuss a concept that you most likely came across during your high school or middle school math classes. This concept is functions. Believe it or not, few people actually understand what a function truly means. In this somewhat brief video, we'll clear up any confusion around the concept of a function. We will also talk about its notation and the key differences between equations and functions, while pointing out their importance at the end of the video. By the way, the video is divided into time-stamped sections as indicated in the description, so feel free to jump to any part you're interested in. To reinforce your understanding, I encourage you to take a simple, short quiz after watching this video. Its link is in the description. If you're new to our channel and enjoy the content, don't forget to like, subscribe, and click the notification bell to stay updated with our latest videos. Now let's get started. Let's begin by providing a somewhat informal definition of a function to avoid overcomplicating things with difficult math terminology. Simply put, a function is a relationship between two values. Let's call them x and y. Based on one variable, we can determine the value of the other. A function is often likened to a box into which you input a value, and through a mathematical relationship, the box gives you an output. To make this clearer with an example, imagine we have a function that squares the input and then adds 4. Mathematically, the function could be written as input squared plus 4. If we input the number 3 into the box, the output will be 13, because 3 squared plus 4 equals 13. If we input -2, the output will be 8, because -2 squared plus 4 equals 8. Another way to understand this is to think of the function as a set of inputs and outputs. The inputs represent the values of x, and the outputs represent the values of y. This can be visually represented by a diagram that shows how each input is connected to its corresponding output. In fact, this is the official definition of a function in mathematics. A function is a relationship that links each element from the input set, x, to only one element in the output set, y. Now let's move on to the most important point in this video, the difference between equations and functions. There are two main rules to consider when determining whether an equation represents a function. First rule, an output, y, can correspond to more than one input, x. Second rule, an input, x, cannot correspond to more than one output, y. This might sound complicated at first, so let me break it down. Take for example the equation y equals x squared plus 4, which when graphed forms a curve. Notice that when x equals 0, y equals 4, and when x equals 2 or -2, y equals 8. This relationship holds true and follows the rules of a function. Now let's look at another equation, x squared plus y squared equals 1, which represents a circle. In this case, when x equals 0, y can be either 1 or -1, because y equals plus or minus the square root of 1 minus x squared. This violates the second rule of functions, as one input, x, corresponds to two outputs, y, meaning this equation does not represent a function. To summarize the first equation, y equals x squared plus 4, is a function, while the second equation, x squared plus y squared equals 1, is not. One way to test whether a graph represents a function is to use the vertical line test. If a vertical line crosses the graph at more than one point, the graph does not represent a function. In conclusion, these rules help determine whether a mathematical relationship qualifies as a function. For example, if we have two mathematical relationships, s equals 3 and t equals 3, both represent the speed of a car over time. The graph of s equals 3 is logical, meaning that at every moment in time the car has a constant speed of 3 meters per second. However, the graph of t equals 3 makes no sense, as it implies that at a single moment in time, the car has every possible speed. This demonstrates why we have conditions for defining functions. A function must describe how one value changes in relation to another. The relationship s equals 3, which forms a horizontal line, is a function, while t equals 3, which forms a vertical line, is not. Lastly, let's talk about function notation. We previously used the example y equals x squared plus 4, where we could create a table of values for both x and y. However, in mathematics, we often use a more formal notation y of x equals x squared plus 4. This notation is crucial because it explicitly states that y is a function of x. For example, y of 2 means the value of y when x equals 2, and in this case y equals 2 squared plus 4 equals 8. This is the basic idea behind function notation. Using this notation makes it easier to express the relationship between the variables, and will become more important as you advance in mathematics. That's it for today's video. To learn more about the importance of functions, check out our full episode on this topic, where we explore real-life examples. You can find the link in the description or in the video's suggested cards. Don't forget to take the quiz at the end of the video, and thank you for watching. If you enjoyed this content, please like, subscribe, and click the bell icon for updates. You can also become a sponsor of our future episodes by supporting us through the links provided.